This is example number 1A on page 2 in regards to you're given information now that uniquely describes a quadratic function, and we want to be able to write that equation in a variety of forms or find other properties of that function. So in example number 1, you're given a vertex, so you're told the h value is 2 and the k value is -6. That's what the vertex tells you. You're 2 to the right and 6 down. You're also given a point 0 and -2, and that's a special point. That is the y-intercept. But at this point in time, what you really know is that when x is 0, the y value is -2. So if you look at your equation, y equals a times x minus h squared plus k, you have 5 variables in there. You have 5 parameters. You have x, y, a, h, and k. And you're given 4 of them, which means really what we got to do is confirm that we know how to find the value of a. Then after you find the value of a, you can write the equation, which is you write the expression where you don't substitute in every known value of x and y. You leave those values of x and y as the unknowns, and that's how the points appear on a graph. So let's just plug in what we know. Our x and y, -2 is equal to a times 0 minus h, so -2, so you have x minus h squared and plus k, so in this case it's -6. So you end up having a two-step equation that you're going to solve. Don't break any rules, don't break any order of operations. 0 minus 2 is -2 squared. Again, order of operations here, I need to square first. -2 times -2 is 4. So my equation is -2 equals 4a minus 6. So just algebra skills. Simplify. 2 steps, add 6 to both sides. -2 plus 6 is 4. So 4 equals 4a. Again, reverse operations. Opposite of multiplying by 4, divide both sides by 4. And 4 divided by 4 is 1. So it happens that this equation has your basic stretch. The stretch value is 1. So if you go back to write the equation, then you're going to use a as 1. You're going to use the h value, which was 2, and you're going to use the k value, which was -6, and write an equation for that. So your equation, y equals a times x minus h squared plus k, is y equals, a is 1, so you don't have to write it. It's implied, x minus 2 squared minus 6. So that's the answer that we wanted for part A. Take the information about points, put it into a format that is best suited for your information, and then write the equation for that. Part B of our question, we're supposed to find the zeros of x minus 2 squared minus 6. Everything that we've used to find zeros before, we started off with y equals a x squared plus bx plus c, and we made that equation equal to 0. So let's not deviate from that format. Let's take our expression x minus 2 squared minus 6, and let's just change forms for it. So I have y equals x minus 2 times x minus 2 and minus 6. So that's like the 0 format that we have up top, but we're not equaling 0. So it's a little bit dangerous to think of it that way. Multiplying this out is x squared minus 2x plus 4. I still have the minus 6 on the end. So I have y equals x squared minus 4x minus 2. Looks like we're still kind of recording here, which is good. We're supposed to solve this now. We want to go 0 equals x squared minus 4x minus 2. If you look at that equation, you're going to say nothing multiplies to give me -2 and adds to -4. So let's use the quadratic formula. Again, we haven't used it a whole lot, so let's just write it down. -b plus or minus square root of b squared minus 4ac all over 2a. So if I'm going to find my zeros, b value is -4, so then that becomes +4. -4 squared is 16 minus 4 times a times c. c is -2 all over 2 times a all over 2 times 1. So we have a bunch of math in here. 16 plus 8 is 24 all over 2. And I know 24 is 4 times 6, which is 2 root 6. So I want to use that information or those thoughts to help me simplify my radical to a mixed radical. 4 plus or minus 2 root 6 all over 2. All those terms divide by 2, so it's 2 plus or minus root 6 are my 2 zeros. And that's a good answer. I can leave it like that. The last thing we want to do is take this information again and look at the range. And again, the range is nothing more than thinking about where's my vertex and which way does my function open. So if we just kind of scroll back up to our equation, x minus 2 squared minus 6, y equals x minus 2 squared minus 6. I know my vertex is 2 and negative 6. I know the a value was 1, so I know that I'm going to open up. So if I just visually draw myself a real quick sketch of what I have happening here, 2 and negative 6, and my graph is going to open up. I have a minimum value of negative 6. My maximum value is infinity. So kind of like the other examples that we've seen this morning a little bit, because everything's opening up, my range is a set of numbers y all greater than and equal to negative 6. And again, if you want to see kind of how that develops, there is no maximum and the minimum is negative 6. So when you read that from the y value, y is greater than and equal to negative 6. Y is greater than and equal to negative 6. It reads the same way when you read from the y. So that's, again, an example of how you take properties of a function. Most importantly, we're not given the a value, so we can't assume a is 1. We have to show a is 1, or other examples you'll see, find out what the value of a is and use that information to solve for the other properties.